Hey guys, Mr. Milton here. Today we're looking at areas of trapezoids, rhombuses, and kites. At the end of this video, you should be able to find the areas of trapezoids, rhombuses, and kites. All right, area of a trapezoid. Here's our formula for finding that. We'll write it down and then we'll talk about how we get there. The area for a trapezoid is 1/2 base 1 plus base 2, the sum of the bases, times the height. Okay, and really how we get there is kind of a little bit of creativity by somebody. But if you notice who we have a trapezoid here in this image, okay, what we can do with this trapezoid is, see we have another trapezoid here, kind of identical trapezoid. If we piece these two trapezoids together, look what it makes. It makes a parallelogram. And we know that the area of a parallelogram is 1/2 base times height, right? And we're really focused on using that perpendicular height in this chapter, right? So our perpendicular height in our trapezoid, okay? And if you look at the base of the parallelogram in this case, that corresponds with it, that our height is base 1 and base 2, base 1 plus base 2. So really what we have is we have base 1 plus base 2 times height. But remember in this thing that we have two trapezoids together. So in order to find the area of one trapezoid, we just take half of what we found, okay? So remember that the height is always perpendicular to the bases. Okay, so that's just how we find it. I guess if you were like, why are you talking so long about that? Remember this is the formula. Area equals 1/2 base 1 plus base 2 times height. Okay, so that's what we need. So here, let's look at a few examples. It says find the areas of each of the trapezoids below. Leave answers in simplest radical form. Okay, so our first trapezoid, we're given really everything we need. Just make sure that you identify the bases as the parallel sides, right? Okay, and so those parallel sides should be the bases in the trapezoid. So area equals 1/2 base 1, 20, plus base 2, 25, times our height, our perpendicular height, 15. Okay, so pretty easy question in the sense that they gave us everything we need to know. So 1/2 times 45 times 15. And that will give us 7.5 times 45, 337.5. Okay, and in this case, centimeters squared. We wouldn't be able to write it in simplest radical form because there's no need for radical. Okay. Number 2. You'll notice number 2 that we are not given that height initially, but they did give us that angle P is 60 degrees. So using our special right triangle knowledge here and a little bit of basic geometry, if this is 5, this is perpendicular, right? So this must be 5. So then this leg of this triangle is 2. This is a 30, 60, 90 triangle. Okay, we know that across from 30 is x, across from 60 is x times radical 3. This would be 2x, even though nobody really cares about it at this point. But we find that our height then must be 2 radical 3. So we find our area. Area equals 1/2 the base 1 plus base 2, so 5 plus 7, 12. Times our height, which is 2 radical 3. And so as you multiply stuff across, 6 times 2 radical 3 gives us 12 radical 3 meters squared. Okie doke, looking at number 3. Trapezoid is isosceles trapezoid, but that doesn't change our formula. We need to find base 1 plus base 2 times height. So as we look at what we're given, we have to find, well, we have base 1, which is 5. We have our height, which is 8, but we don't have base 2. Okay, so let's try to see if we can figure that out. This is a rectangle. Kind of tell by the perpendiculars, right? It must be a rectangle. So this is 5, that's 5. Okay. In this triangle, as funky as it looks, this is marking or denoting for us that this is congruent. and this is a right angle. So that must make this a 45, 45, 90 triangle. Okay, remember in 45, 45, 90 triangles, our legs are congruent. So if this is 8, that must mean that this is 8. No, visually, you're like, how is that 8? This is 5. But remember, math trumps visuals. All right. And then on this other side, this is 8, but we're not really given anything about the special triangle here. So we have to use Pythagorean theorem over here, and we can say, that's the hypotenuse, 10 squared must equal 8 squared plus, let's say b squared. Okay, so that's 100 minus 64 gives us 36. So b squared is 36, b then must be 6. All right, so now all that math to find what our second base was, and that is 11, 19. So 5 plus 19 is 24. Area equals 1/2 24 times 8, 12 times 8, which is 96. So the area of this trapezoid was 96 feet squared. Okay, number 4. Base 130, and we're not given base 2 or the height, but we are given that this is a right triangle. We can figure that out. And that this angle's 2x and this angle's x. Well, in a right triangle, in a triangle altogether, it has to add up to 180 degrees. So since we have 90 here, we have 3x equals 90 for the rest of these other two angles. So 3x equals 90, that must mean that x is 30. So we have a 30, 60, 90 triangle here. Okay, with a given hypotenuse, so 2s is 14, that must mean that s is 7, right? And this is s radical 3. So this side is 7. Use my other color for this one. This side is 7. This side must be 7 radical 3. That helps us to find our second base as well, since this whole thing is 30. Since this whole thing is 30 and this part's 7, that must mean the remaining is 23. So now we have everything we need to know for this triangle. Area equals 1/2 base 1 plus base 2, which is 53, times our height, which is 7 radical 3. Okay, so multiplying that, 7 times 53 times 1/2. I'll do that. 7 times 53, 7 times 53 gives us 371. Okay, so area equals 371 radical 3. And if we're putting it in simplest radical form, which they asked us to, we typically write it like this. 371 radical 3, over 2. Guess I didn't give myself enough space. Okay, so simplest radical form typically does not use decimals. So in the two problems where we had a radical, we did not use a decimal. In the problem that we didn't have a radical, we did. Sorry. All right, that's trapezoids. To find the area of a rhombus or kite, how we did that was we found our formula, which is area equals 1/2 diagonal 1 times diagonal 2. And that is for rhombuses and kites. It says use the figure below to justify the formula for a kite. And so here's what we're looking at. When you look at this kite, we have a triangle in here. Okay, you'll see that we basically were able to write or make an identical triangle, kind of make that a square, say at least a parallelogram. Okay, same thing here. Doubled it. We doubled this triangle. We doubled this triangle. And what we have now is a whole parallelogram. Okay, and when we look at the dimensions of these parallelograms, the dimension here, use a different color. The dimension here, diagonal 2, is this length. The dimension here is this length. Okay, and we know that they're perpendicular with each other. So in a parallelogram, we'd have area equals diagonal 1 times diagonal 2. That's of this parallelogram. But then you see, like, wait a second, all the green pieces aren't really a part of our kite. And it's half of the stuff. We divide it by 2. Okay, so area equals 1/2 diagonal 1 times diagonal 2, or area equals diagonal 1 times diagonal 2 divided by 2. Either way, same thing. Okay, we can do the same thing for a rhombus. So here in this next section, we're actually using that formula now. It says find the area of each kite and rhombus. And this first problem, given that AB is congruent to BC, is congruent to CD, is congruent to DA. So this is telling us that this is a rhombus. Again, we still have that perpendicular diagonals, and so works out still. And so as we look at this, if this is a rhombus, this is 12, this is 12, right? Because we know that diagonals of a quadrilateral, or sorry, of a parallelogram bisect each other. Okay, and so we need to use something to find out what this other diagonal is. And since these are right triangles, we can use Pythagorean's theorem. 15 squared equals 12 squared plus, I'll just say d squared. Okay, so finding out what d squared is, that should be 225 minus 144, and that's 81. Oh, that's nice. All right, so d squared is 81. That must mean that d is 9. So 9 and 9. Okay, remember that as we find our area equals 1/2. Diagonal 1 is this whole diagonal, all of BD. And that's 18, okay, not just 9. Diagonal 2 is the whole diagonal. That's 24, not just 12. So now as we multiply it through, 1/2 times 24 times 18, and that gives us 216. So the area of this rhombus is 216 meters squared. Okay, number 2, it's a kite. Nice, kind of had to give us a little bit more information. It says given that KM is perpendicular in L, so it's a kite. Our diagonal 1 would be here at 7, 2 plus 5. Our diagonal 2, here's 6. So we have 3 times 7, which is 21 meters squared. And then our last one here, it says, given that the perimeter is 72 degrees, find the area. And so they marked it for us that all these are the same. So it must be a rhombus. 72 divided evenly among 4 sides is 18. 18, 18, 18, 18. All right, great. It is a rhombus, so we know that the diagonals are perpendicular. So that helps us out here. And then, because it's a rhombus, we know that our angles bisect each other here. Parallelogram, so our opposite angles are congruent. Okay, a triangle here, so this is 60. Rhombus bisect each other. Parallelogram, opposite angles are congruent. We have 4 30, 60, 90 triangles, where we're given the hypotenuse is 18. So in the 30, 60, 90 triangle, we know that 2x is our hypotenuse, across from 30 is x, and across from 60 is x radical 3. So if 2x is 18, that must mean that x is 9, and x radical 3 is 9 radical 3. Okay, so we have all of our sides. Now we can find our diagonals. As we set this up, area equals 1/2 diagonal 1, which is 9 plus 9, 18. Times diagonal 2, which is 9 radical 3 plus 9 radical 3, which is 18 radical 3. As we multiply that, 9 times 18 radical 3 gives us 162 radical 3. Let me check on my calculator. Probably should have done that first. 9 times 18, 162. All right, great. And what units do they give us? Centimeters squared. All right, so there we have it. Finding the area of trapezoids and kites and rhombuses. See ya.